Data orchestration is important for all industries that use data, but especially those where data is their principal product, whether that's making movies, designing drugs and genomics, or designing microchips. All of these industry data actually is the product. But even outside of those, every other industry is also today driven by data. And it's not just the structured data, but also unstructured data. And it's not just the most recent data, it's all data. So what we're seeing is a true transformation where all data needs to be orchestrated. All data needs to be available at your fingertips. The need that's driving this next data cycle is the competitive business environment that we live in today. To stay competitive as a business, you have to be able to hire people potentially around the globe. They expect to be able to work from home and maybe even their home country. You have to be able to do your computing wherever you have economic resources to do that on. You have to be able to retain your data where it's appropriate to do so from a legal regulation perspective. So the driver really isn't new, it's the competitive nature, but now it's become all the more urgent to be able to extract the most value from data as possible. The businesses that are going to win in the next data cycle are those that can bring automation to bear to incorporate more data more quickly. So in the next data cycle, data is being generated at the edge and being used in the cloud or on-prem. The key here is to be able to decentralize the data to support a decentralized workforce, support decentralized computing resources. You have to be able to tap into whether it's human resources or compute resources anywhere in the world. And we're seeing this not just in the world of data and compute, but in physical supply chains. This same need to build something that is much more robust through being agile. There's an added urgency to this when we look at the opportunity that we're presented with AI and ML. It's going to be the companies who can work with large quantities of data across decentralized resources and bring that to bear with this new class of application that we're seeing today. It's a game changer, and the companies that can use that are the ones that are going to have the competitive advantage. Data architectures are fundamentally changing to address these new business drivers. We're moving from a world where data is manually stored, copied, merged, cataloged, to a world where data becomes fully orchestrated and is simply available anywhere and everywhere you need it all of the time. Different than the world where data is stored in a single centralized silo and all of the computing and work has to be done there in close proximity to it. What we're talking about here is a fundamentally new architecture. It's an architecture built around the concept of data being an orchestrated asset, not something that's stored and manually copied and merged. This allows data to be itself decentralized and available around the world to anybody who needs to use it. So data architectures are fundamentally changing in this next data cycle. Instead of data being a centralized resource that is stored and maybe manually copied and merged, it is becoming an orchestrated asset to where it permeates the environment and can be accessed from within any data center, by any application, by any user. And this allows businesses to have that agility to extract more value from their data more quickly. Data architectures, until now, have been bound by data gravity. With data orchestration, they are no longer bound by data gravity. One of the key defining features of this new data architecture is that you not only have your data wherever you need it through orchestration, but that it is delivered at a new level of performance that was not achievable before. We have to be able to have our cake and eat it too, and have data be where you need it and be at the performance levels that you need it. This really is a hat trick in that you are able to have the data everywhere and have it at the extreme performance levels that these new AI, ML analytics systems need. In the past, data architectures have been defined by the storage systems serving that data. In the future, data architectures will be defined by the data orchestration platform. And that's where you get the opportunity to introduce true parallelism and to get to a new level of performance. Not only do we have these new applications, AI, ML, analytics, that are driving increasing needs for performance, but we have the opportunity with ever advancing hardware and ever more specialized hardware for these applications. They need to have data delivered in parallel and with shorter data paths that data orchestration uniquely can offer. As I was saying, data architectures have in the past been defined by the storage system. This is because the data presentation layer, the thing which is giving you the perception and view of data, the file system, has been embedded within the storage system. Data is a platform layer construct, and yet you have it being subordinated to infrastructure. Platform is supposed to be on top of infrastructure, not beneath it. And yet that's what you get when you have file systems embedded within the storage. Even worse, when you need to have that data available in a decentralized fashion across different data centers, you're left with having to make copies. And those copies are a fork of the very existence of the data at a specific point in time where it gets orphaned, abandoned, and is now a different piece of data. This grows as an exponential challenge as you start introducing more and more places where you need to be working with the data. So we have to move past the store, copy, and merge model for presenting and accessing data. In the next data cycle, data architectures need to be done fundamentally differently. The first thing we have to do is to take the file system out from under the storage infrastructure so that data is no longer subordinate to infrastructure. And this is precisely what we have done at Hammerspace. We have built a file system that is capable of extending across decentralized infrastructure of any type in any location, and have it still be the same file system and the same data. That allows you to have global access from anywhere at any time to any data. More importantly, what that allows us to do is to take data management and fundamentally transform it into something very different, to data orchestration. The difference being that data orchestration is fully automated using AI and ML and is able to predictively move data to where it is going to be needed or where it is currently being asked for, and do that in a way that does not disrupt the ongoing use of that data, because it is now behind the file system, behind the data presentation layer. It no longer disrupts your access. And what that means is that storage can now recede into the background as interchangeable infrastructure as it should be. This allows data to transcend infrastructure and to become a global asset that is accessible and available everywhere, continuously, without interruption. By having this global data presentation layer, a global file system, it allows us to fundamentally change data management and transform it into something very different. It allows data management to become data orchestration, where the defining difference is that data can now move in a way that doesn't disrupt the view of the data, doesn't disrupt access to the data. Data's movements are transparent to the use of the data. This allows us to, for the first time, truly automate the movement of data. Using AI and ML, you can now predictively place data where you're going to need to use it. You can reactively adapt to the use of data. And ultimately, this allows us to take the storage infrastructure and allow it to recede into the background where it ought to be. Not because all storage is the same, but precisely the opposite, because storage systems have many diverse design points and serve different functions, and data over its lifetime needs to be stored on different types of storage. Sometimes for performance, sometimes for long-term retention, sometimes closer to site A, sometimes closer to site B. And that's why we ultimately have to be able to move from a store, copy, and merge model to a fully orchestrated model. What this ultimately means, very fundamentally, is that we're taking applications who used to be at a very great distance from their data and making it so applications are now adjacent to the data presentation layer. That allows these applications to become smarter about how they use data across a physically distributed infrastructure. So as you can see, this is a very fundamental change in architecture. And that's one of the reasons why it has been so important that this be done as a standard and in open source. This is where I'd like to call out our CTO and many of our advisors. Trond Mikkelbust is the kernel maintainer of the storage networking stack in Linux, where this is fundamentally made possible. And Gary Greider is one of the early advocates of this type of architecture going back over a decade. And then Kai Lee, who introduced fundamental architectural changes in how we do disk-to-disk backup and dedupe, E.L. Waldman, who introduced new forms of high-performance networking in InfiniBand. They've all been key to driving this as an open standard based solution.